Welcome to part 6 of Unbinding Prometheus, how generative AI liberates computational thinking from coding. This part of my presentation explores how generative AI is transforming and disrupting the workforce by automating entry-level jobs, elevating the value of adaptability, and reshaping how humans collaborate with technology. I also describe how William & Mary is future-proofing its graduates through 5 pillars: interdisciplinary learning, accelerated degree pathways, internships, research integration, and digital communication, ensuring students become creative, AI-literate professionals ready to thrive in a hybrid AI-human workforce. The commoditization of computational thinking isn't all progress and promise. It also brings large-scale upheaval that's reshaping how we work, learn, and create. For example, knowledge work, once the domain of specialists, is now increasingly computational and thus accessible to nearly anyone with an internet connection. As with automation's impact on manufacturing and blue-collar jobs over many decades, AI is reshaping creative and cognitive white-collar jobs, replacing some tasks while redefining others. The real risk isn't that AI will instantly take your job. It's that someone who uses it more effectively will. In this new landscape, the advantage belongs not to the most knowledgeable, but to the most adaptive, the humans who learn to collaborate fluently with their digital counterparts. Employers today aren't just looking for candidates with strong foundational knowledge. They want analytical thinkers who can reason fluently with AI tools and platforms. It's no longer enough to simply understand the principles. They expect employees to apply those principles through generative AI to enhance insight, automate work, accelerate workflows, and create value. The good news is that anyone with curiosity and commitment can master these AI tools, unlocking a new level of creativity, capability, and competitive edge. In fact, studies indicate that novices benefit from AI even more than experts. So why does this shift, marked by the rise of AI-fluent collaboration, the advent of prompt engineering, and the commoditization of computational thinking, matter to us as computer scientists, teachers, and students? Well, the truth is that the ground beneath our profession is shifting fast. Fortune recently reported that nearly half of Gen Z and millennials believe college was a waste of money, and that AI has already made their degrees obsolete. That's a gut punch when we're asking families and students to invest 4 years and hundreds of thousands of dollars in a computing education. Meanwhile, the first rung of the career ladder, the entry-level job, is breaking. A senior leader at LinkedIn put it bluntly: even before generative AI, entry-level roles were drying up. But now automation and AI co-pilots are accelerating that trend. For example, the chart on this slide shows that entry-level tech hiring dropped sharply in 2024, down nearly 25% at big tech firms and 11% at startups, despite an overall rebound in tech employment. Meanwhile, companies are prioritizing mid to senior level hires, defined as 2 to 10 plus years of experience, signaling a shift toward AI-driven productivity that favors experienced professionals over new graduates. What's happening in computing today echoes what's already transformed medicine, journalism, and finance over the past decade. The easy on-ramps are disappearing. So where does that leave us? How can we remain competitive in a world where AI can code? Studies show that AI can already code better than many humans, which is having a deep impact on how we teach, learn, and practice computer science. The evolution is visible, from early human programmers at mainframes to teams collaborating with intelligent systems, to a new era where humans guide AI in reasoning and design. It's a computer science revolution with far-reaching implications for every field that depends on logic, creativity, and problem solving. Here's one way to visualize the disruptions that are occurring. Imagine the talent pipeline for software. At one end are the dabblers and software makers, people experimenting with vibe coding, building prototypes, and using AI tools to create quickly but informally. In the middle lies the largest group: junior developers, recent grads, and early career coders forming the bulk of today's computing workforce. And on the far end are the senior developers, seasoned engineers who know how to architect, scale, and debug complex systems. Due to generative AI, the middle of the software talent curve is hollowing out. The traditional pipeline that once flowed from junior to senior developer is breaking down, as AI systems now perform much of the routine coding once assigned to entry-level engineers. What remains are the two growing edges: creators and dabblers who use generative AI to craft software without conventional programming expertise, and senior developers who can design, orchestrate, and oversee increasingly automated and intelligent systems. This trend underscores the challenge and the opportunity for us at William & Mary and other universities conferring degrees in computer science. In particular, how do we help our students accelerate their journey from junior to senior developers faster? How do we empower non-experts, majors in economics, biology, government, or philosophy who minor in data science or AI to build production-quality software-reliant systems, not just dabble? And most importantly, how do we devise a world where humans and AI collaborate seamlessly, where creativity and competence, not just credentials, define capability and competitiveness? The real question is this: how do we upskill our workforce and ourselves fast enough to stay competitive in the face of seismic technological shifts? The recent government shutdown was a wake-up call for the Washington, D.C. region. But the truth is, the pressure started well before that. Across agencies and contractors, hiring freezes and attrition have left teams with fewer people and the same or greater workloads. When that happens, there's only one move left: turn to automation and AI. Not as a shiny new toy, but as a survival tool. The question is no longer if people will adopt AI, it's whether they can master it fast enough to stay productive, relevant, and resilient when the margin for error keeps shrinking and there are fewer hands on deck. While it's tempting to charge uncritically into the AI revolution, this moment demands reflection as much as acceleration. The tide of technological change is rising fast, and our human systems, ethics, policy, and education are scrambling to build defenses sturdy enough to withstand it. We're not facing a clean, frictionless transition. We're shoring up the levees of civilization in real time, trying to ensure that progress doesn't wash away the very values that make it meaningful. We'll wrap up this part of my presentation by discussing ways of preparing students for career success in a rapidly changing work environment that's being disrupted by generative AI. At William & Mary School of Computing, Data Sciences, and Physics, we're devising strategies to intentionally future-proof our students. Our goal is to ensure graduates don't just enter the workforce as junior developers or apprentices, but as adaptable, creative, AI-literate professionals ready for whatever comes next. We're tackling that challenge through 5 key strategy pillars. First, we're championing interdisciplinary learning and degrees. A student might double major in economics and computer science, pair data science and business, or a major in psychology with an AI minor. The goal is to produce graduates who don't see the world through a single disciplinary lens, but who can synthesize data and connect ideas across fields. Second, we're expanding bachelor's to master's accelerated pathways. Many of our students come to William & Mary with many AP credits. We want to help them finish a 4-year degree with a master's already in hand, so they graduate not as entry-level talent, but as emerging leaders. Third, we're expanding internships and co-ops that connect students directly to the intersecting worlds of government, industry, and research. Whether they're working with federal agencies, defense partners, or innovation labs, these experiences place students at the heart of real-world collaboration, where policy meets practice and ideas become impact. Graduates who understand how teams operate across these sectors don't just enter the workforce, they strengthen the bridge between discovery, application, and public good. Fourth, we're embedding undergraduate research at the heart of the William & Mary experience. We're already known for exceptional undergraduate teaching, but in fast-moving fields like computing, data science, and AI, you can't teach effectively if you don't operate at the cutting edge. Our talented teachers are also active researchers. because research keeps our teaching alive, relevant, and future-focused. And finally, we're helping students learn how to communicate digitally. Increasingly, job interviews happen over Zoom-like platforms, such as Big Interview, where candidates speak to an AI interviewer. That requires confidence, presence, and adaptability, skills most students haven't had to develop unless they aspire to a career as a YouTuber. So, we're using AI itself to help them practice, receive feedback, and master the art of presenting themselves professionally on camera. All 5 pillars serve a single mission: to help our students move faster up the learning curve, thrive in a hybrid human-AI workforce, and stand out not just for what they know, but for how they think, adapt, and communicate. This concludes the 6th part of my talk on how generative AI is liberating computational thinking from code. In part 7, we'll explore how generative AI errors often arise from poor use or lack of context, and discuss how responsible, well-informed AI adoption, guided by ethical, educational, and environmental awareness, can enhance learning while preserving critical human reasoning.